very quiet. There are no solar flares, and the plasma filaments are remaining mostly calm. We do have the coronal hole stream impact expected off the southern opening, and the solar wind might be beginning to present that enhancement over on the right side of the chart. Telemetry beginning to change here today. Highest solar wind speeds would still be hours to maybe a day away. Let's jump back in time, though. 10 years ago today, there was a titanic solar eruption that offered one of the prettiest views of a flare in CME that humans have ever seen. The eruption was so massive, not all the ejecta was able to exit the corona, with clear splashdown effects of the plasma re-entering the lower regions of the solar atmosphere. Some of that plasma was even forced all the way over the limb onto the far side of the sun. The eruption was massive on coronagraphs as well. The speckly, staticky view immediately upon the eruption being seen is the proton surge along the interplanetary magnetic fields. Calm to proton storm conditions as the flare occurs, and we awaited the CME. Doubt we'll have anything of that magnitude here today, but this level of activity is expected in the coming few years as we hit sunspot maximum. Interesting note on a massive undertaking to resolve the classical nova fluoride production. Well, it didn't work. They still don't have their answers. But for those who don't know what a classical nova is, let's squeeze some teaching out of the topic. Top two things on the list are one-time events for the most part, destroying the star, even though some supernova have failed to fully do that. For the most part, however, everything else on this list is repeating. These span the energy range from comparable to normal solar flares, and that includes the dwarf nova range, to planet-destroying blasts of classical nova, with some on the recurrence timescale of millions of years between nova events, while others we know recur rapidly on the years to decades scale. Our sun's micronova is somewhere in the middle, about 12,000 years apart. Let's get some geology papers we missed from last month. This one focuses on the Banning Strand of the San Andreas fault line. Historically, it has gone off with a regularity that now puts it overdue for a major rupture. And you might recall, it was March 25th's morning show where we heard the same thing about significant strain built up in the same region. FYI, the Banning Strand is east of LA near the Coachella Valley. This next one we actually didn't miss, but we incorrectly missed one of the fun aspects of the paper when we shared it. We shared how it was able to identify the Heinrich Event 1 and the cooling it caused at lower latitudes. But most of the study pings both the Gothenburg and Younger Dryas disaster 12,000 years ago and the Helena-Pali magnetic event 18,000 years ago and Heinrich Event 1. FYI, the green and black thin lines are the discarded but potentially correct data, and if you use that data, it actually pushes that red down spike on the side from around 16,000 to 18,000 years ago, where it belongs. They also did notice stark hiatus periods and other corings from areas that we said spend some time at the polar region every other cycle. Hiatus from deposition, indeed. While we're on the topic, last night's special video was a don't miss it. How the lopsided Earth's core plays into the geophysical aspects of the disaster cycle. And if you didn't catch it, do so. And while we did show the full disaster playlist twice, and even said it would answer almost all of your questions on the catastrophe, well, chuckle, veteran observers, I think you probably can guess what happened in the comment section. Last but not least, an excellent piece on the global scale effects of space weather and climate, solar forcing. While the global electric circuit allows regional and localized effects to occur on the minute's time scale, and the input to the oceans doesn't come back out for 20 to 30 years, the core forcing on things like surface temperature, monsoon patterns, El Nino, those are on a lag of 2 to 3 years. Many in the community had been expecting this tightening of the lag after most of the last decade called for a 1 to 4 year lag in temperature and major oscillations. We're now down to 2 to 3. The geomagnetic maximum in the sunspot cycle does tend to trail the sunspot cycle, so it is the better match. We went over a lot of these lags in Chapter 4 of our textbook, Weatherman's Guide to the Sun. It and our catastrophism book.